essential prime implicants for the K-map shown below is here. First of all, we have to group the squares such that here this one and this forms the quad, again this forms the quad, here these two squares and these two squares forms the quad. But there are multiple possibilities for these minterms which we have been grouped together. But if we comes to this square, this is the only possibility, as well as for this square this is the only possibility. Again for this square this is the only possibility. Hence there are three essential prime implicants are there. Those are indicated by 1, 2, 3. So if we write the expression for the prime implicant shown in 1, that is D A B bar. For the second prime implicant A bar B. For the third prime implicant, which is D bar again B. So it is A B bar D and B D bar A bar B. Hence option C is correct.
R1 and R2 have the nominal value of 3 ohms and 6 ohms. Okay, each having a tolerance of 10% and 5% respectively. Now, what would be the tolerance in the equivalent resistance R1 and R2 are connected in parallel? Okay, calculating error in parallel resistors is a tricky one, because if you see in numerator and denominator you have same values. Okay, now R equivalent is equal to, when two resistors are connected in parallel, R1 plus R2, and numerator term is R1 into R2. If you see here, we can write this one as 3 ohms plus or minus 10% parallel with R2, that is 6 ohms plus or minus 5% divided by 3 plus or minus 10% plus 6 plus or minus 5%. Okay. Now, how to calculate the error in these two resistors when they are connected in parallel? Okay. If you see here, the limiting error in numerator is 15%, as well as in denominator is also equal to 15%. Okay. So how to calculate this? If you see here directly, you will get it as 30%. But here, since these two resistors are connected in parallel, numerator terms and denominator terms are same. Okay, we should not calculate addition, subtraction or division properties in limiting errors. So what we have to do is, we have to take two worst cases of all. Okay, what are the worst cases here? See here, 3 plus or minus 10% means worst case will be 3.3 and 2.7. Similarly, for 6 ohms resistance it will be 5% means 6.3 and 5.7. These are the worst cases we have. Okay, now R equivalent for the first worst case, that is both resistors having positive error of maximum value. Okay, now I can write this one as 3.3 multiplied by 6.3 divided by 3.3 plus 6.3. You will get it around 2.16 ohms. Similarly, R equivalent to is equal to worst case with minus 10% and minus 5% respectively, that is 2.7 into 5.7 divided by 2.7 plus 5.7, which is equal to, we will get it around 1.83 approximately. Let us consider it as 1.84 ohms, 836. Okay. Now if you see here, in these two cases, the deviation from the R equivalent value, that is true values are 3 into 6 by 3 plus 6, which is equal to 2 ohms. This is R equivalent. Let us take it as true value. But the deviations are around 0.16 in both cases approximately. So percentage error in this parallel connected resistance is equal to 0.16 divided by 2 into 100. Okay, you will get approximately 8%. So option D is correct answer.
From the power supplied by the current sources. Here, current source as well as the voltage source are comes in series. Here the resistance value is 2.5 ohm. So the current through the voltage source is also 2.5 ohm, means 2 amps. So the voltage developed across the 2.5 ohms is the 5 volts. If we apply the KVL in the loop, then we will get the voltage across the current source as 5 volts. Again the polarity is given like this. Hence now the current is entering the positive terminal in the current source. That means the current source is absorbing the power. So power absorbed by the current source is nothing but voltage across the current source and the amount of current it is allowing through it. So 5 into 2, which is 10 watts, 10 watts and absorbed. Hence option D is correct. Pair of Zener diodes, each with a forward drop of 0.7 and the Zener diode voltage of 4.7 volts is connected as shown in the figure. The input voltage is a sinusoidal function, that is 10 sine of 2t. The peak to peak output voltage is, see, if we indicate two diodes D1 and D2, when Vs is the positive half cycle, then D2 is going to conduct whose forward drop is 0.7, hence D1 is not going to be reverse breakdown. Hence the output voltage is towards the positive peak side, it is plus 0.7, and the negative half cycle of the Vs, the D1 is going to conduct whose forward drop is now 0.7, hence D2 is not going to be in breakdown region. Hence negative peak side is, it is going to be minus 0.7, hence peak to peak voltage is going to be 1.4 volts, hence option C is correct.
Calculate the torque developed by a three-phase 4-pole induction motor at synchronous speed. Okay, at synchronous speed we have to find the torque of induction motor. Okay, now what is the synchronous speed of this machine? Synchronous speed of the machine Ns is given as 120 into F by P. Okay, so 120 into frequency is, let us take it as some frequency 50 Hertz. Okay, number of poles is equal to 4. This is 1500 RPM. Okay, that means rotor speed is equal to synchronous speed. This is also equal to 1500 RPM. Now slip is defined as Nr minus Ns minus Nr by Ns. Okay, this is equal to 0. Torque is directly proportional to slip. What does it mean that torque is equal to 0? At synchronous speed Ns, torque value is always 0 in induction motor. So 0 Newton meter, option B is the answer.